Hi, my dear students. As you are I think you will be are preparing for IIT main examinations, which is the best critical examination that you are going to face. For this examination, preparation should be different, as you people should clearly understand the subject, and also analytically and critically you have to think over the subject and points, and you have to apply these formulas or points or the scenarios to the particular situations which suits to the description that has been given to the questions. So that technique has to be learned more important in this one. It will not be taught in your classrooms. You yourself has to think how to get such a technique and how to improve that power of critically thinking and method of solving the techniques in solving the problems. So here, motion in the straight line, I am going to discuss about the motion on straight line. For this synopsis or points or the formulas you can get from any textbooks. If you want, in some other time I will give you the synopsis also. But first, as you are preparing for the examinations, you will be well versed with the formulas that can be used in these examinations. So now I am discussing about some of the questions which have been asked in this examination previously. So in first question that I am discussing in means, a projectile is moving vertically upwards with a velocity of 200 meters, breaks down into two equal parts at the height of 490 meters. One part is moving with vertically upwards with a velocity of 400 meters. How much time the other part will take to reach the ground? So here, by reading this first question, we will get an idea that first we have to use the conservation of momentum for this situation. Here, at first the body is moving with a velocity of 200 meters per second. In second scenario, and means in the second position, the body is split into two parts, and one part is moving with 400 meters per second, and other part we have to find out using the conservation of momentum theory. Initial momentum is equal to final momentum. Here, that we can, in a mathematical way, you can say that mu is equal to m by 2 v1 plus m by 2 v2. Here mu is equal to initial velocity, where m is the mass of the whole body and v is the initial velocity, and in final momentum we are using m by 2 v1 plus m by 2 v2. Then using the numerical values for initial velocity 200 meters and v1 for 400 meters, we can substitute that one. Then we will get m into 200 is equal to m into 200 plus m by 2 v2. Therefore, m by 2 v2 is equal to 200m minus 200m. That means, using simple mathematical transformation, m by v2 is equal m by 2 v2 is equal to 200 meters minus 200 meters is equal to 0. Therefore, m by 2 v2 is equal to 0. As m mass cannot be equal to 0, v2 should be 0. That means the second particle velocity should be 0. As it at the height of the 400 meters, it has to be 0. That means when one part moving upward got double of the velocity, in the sense it has to be get by kicking the second part which is moving with this 200 meters in the same direction. That means with 200 meters, as it is moving 200 meters, it has to be kicked down with 200 meters down, so that the other particles velocity will be doubled. That means 400 meters. From this critically thinking or analysis also, we can say v2 is equal to 0. Here v2 is equal to 0 at a height of 400 meters, v2 is equal to 0. g is equal to 9.8, s1 is equal to, that is height is equal to, displacement is equal to, height is equal to 490 meters. Then using distance is equal to, height is equal to half gt square, 490 is equal to half 9.8 into t square. Then using the mathematical calculations and cancelling, t square is equal to, will get 100, t is equal to 10 seconds. Going to the second problem. A particle is moves in a straight line with retardation proportional to the displacement. Its loss of kinetic energy for a displacement is proportional to. Here this description clearly we can say that it is belongs to this simple harmonic motion. In simple harmonic motion also retardation is proportional to x, and also loss of kinetic energy is proportional to x square. Using this scenario, we can say that kinetic energy Ke is equal to half m omega square a square minus x square. That is the formula for kinetic energy at any stage. Therefore, here m is constant, omega is constant, omega is angular velocity, a is amplitude. Therefore, Ke is proportional to x square. So from this we can say loss of kinetic energy, loss of minus sign indicates loss of kinetic energy, loss of kinetic energy is proportional to the x square. Next, going to the third question. The particles having same range when with two different angles of projection. That means if any particle has been projected with the two different of angles of projection, means it has to be, to get the range equal, we have to project the particle into this complementary angles. That means if one particle is projected at theta, then another particle has to be projected at 90 minus theta, so that we will get the range equal. By using the formulas also we can prove that r1 is equal to u square sine 2 theta by g. That is equal to, using the same formula, usual formula, normal formula, and for other particle s2 is equal to u square sine 2 into 90 minus theta. There you will get sine 2, if you multiply 2 with 90 minus theta, we will get 90 minus 2 theta sine 180 minus 2 theta, which is also r2 is equal to u square sine 2 theta by g. From this we can say r1 r2 is equal to r. So r is same for theta or 90 minus theta. Now calculating T1. T1 is equal to 2u sin theta by g. That is usual formula. And for T2 we have to use 2u sin 90 minus theta by g. 90 minus theta is equal to cos theta. Then multiplying the T1 T2 is equal to 4u square sin T2 theta by g square. Here this can be written as 2u square 2u sin theta cos theta by g into g. For 2 sin theta cos theta you can write sin 2 theta. Therefore this can be written as 2u square sin 2 theta by g into g. For r, as r is equal to u square sin 2 theta by g, substituting for u square sin 2 theta, g is equal to r. Therefore T1 T2 is equal to 2 r by g. Therefore we can say T1 T2 is proportional to r. That's now it is clear, I think, from the explanation and calculation. Going to the problem 4. Here, when the velocity time graph has been given, acceleration time graph has been given, the velocity can be got by the differentiation, by velocity can get got by the integration of this acceleration. We can calculate from the graph, which is nothing but area under the cover. Here area curve is nothing but straight line. From this figure we can easily say that area under the cover is nothing but triangle with the coordinate axis as the sides, with the two coordinate axes as the sides. Therefore angle of the triangle will give you the maximum velocity, half base into height. Base as the sides, we can use any of the side as the base and height. Therefore half is equal to 10 into 11 is equal to 55 meters second, the maximum velocity. So that is the correct option. You can get it done.